Yo, ladies and gentlemen, welcome back to a new video. Do you know that you can generate 40 volts from just a 1.5 volt battery? No, you don't. In this video tutorial, we are going to be discovering how I actually generated 40 volts, 30 to 40 volts using just a 1.5 volt cell battery. So do have to buckle up, grab a snacks, and let's dive in. Now, the first component which is going to be coming to your mind, which you're going to be using in this circuitry, is actually the 1.5 volt battery. Yeah, as you can see it right here, I'm actually using a 1.5 volt battery. You can get it, it's actually 1.5 volt AA battery. You can get it from any store, electronic store. You can just get the 1.5 volt AA battery for to make this project, and this is the battery which I'm going to be using to test the project out and to create 30 to 40 volt, which you I got to expect and do what to stay tuned to the end. And if you haven't subscribed, hit the subscribe button. It really means a lot. Let's jump right in. Now you are gonna be wondering, how am I going to actually generate up to 30 to 40 volts out of a 1.5 volt battery? I'm going to be using the Joule Thief principle. Yeah, I know you're actually familiar with the Joule Thief. I actually made a Joule Thief circuitry in about 2 years ago, but I am going to be recreating this kind of Joule Thief circuit. I'm going to be explaining how it works, how everything is done, the connection process, and everything you need to know. But what you just have to know is that I'm going to be using the Joule Thief principle to generate these 30 to 40 volts out of my 1.5 volt battery. And yeah, now, to create the Joule Thief circuit, we need a transistor. We are going to be using a transistor in this Joule Thief circuit to make it more powerful. In my case, I'm going to be using the BD139 power transistor. Yeah, the reason why I chose the BD139 power transistor is because these transistors have more power rating and is actually fast in operating. And right for my circuit, you can use other type of transistors like the 2N222 type of transistors, and other type of great high frequency NPN transistor will be perfectly nice for this project. Now, also the main brain of the Joule Thief circuit is actually the inductor. Yeah, you're going to be needing an inductor to work with the Joule Thief. Yeah, if there's no inductor, there's not going to be oscillation, there's not going to be generation of electricity, and in other words, there's not going to be any boosting of any voltage. So the inductor is the one important component which is needed in a Joule Thief circuit to make the circuit work, resonate, and boost your voltage perfectly. In my case, I'm going to be using this inductor which have 10 turns at 2 each side, resulting in a total output legs of 4. Yeah. Now, talking about the inductor, yeah, in the previous voice note, I actually said that the inductor actually have 4 pin output, but we are not going to be using all the 4 pins. We are going to be joining 2 pins, which is going to be creating our center tab, and we are going to be using the 2 either pins, just like we use our transformer in creating an inverter. Now, this is how it works. Now, you can see the 2 winding right here. You can see one at the left and you can see one at the right. Now, we are going to name these A1 and A2, and we're going to name the other coil B1 and B2. Now, A1 is going to be connected to B2, creating the center tab. Yes, this is how you're going to be connecting it. Follow my steps and you're going to get the circuit working perfectly. A1 is going to be connecting to B2, creating our center tab. Then we are going to be using A2 and B1 as our 2 terminals, which is going to be connected to the project. Follow my steps and you get your circuit working perfectly. Now, let me explain it much better and more understandable. Now, if you don't have a regular already made inductor with 4-leg output, you can create your own inductor by yourself. All you need is just a toroid, and you need a copper wire. Now, you can start to wind about 5 to 10 turns on one side and repeat the same process and wind 5 to 10 turns on the other side, which will amount in total of 4-leg outputs. The first turn is going to be having the starting and the ending, while the second coil is going to be having also the starting and the ending. Now, the starting of the first coil, which I named in the previous voice note A1, is going to be connected to the other coil ending, which is B2. I don't know if you understand it much better. If you don't, let me know in the comment section and I'll explain it much better for you. So the starting coil mount is going to be connected to the second coil ending, creating our center tab. Then the first coil which is called the A2, and the other coil, which is actually called the B1, is going to be our two terminals, which we're going to be using to connect to the circuit and make our circuit working perfectly. I hope you understand. If you don't, let me know in the comment section right away, and I will explain it much better for you to get it. Let's quickly go to the next one. Now, the connections are very simple to make it. Yeah, you can go online and check about Joule Thief circuit. They're very simple to connect, but I'm going to be giving you the guide in this video tutorial. Also, we are going to be using a 1 kilo ohms resistor, which is going to be connected to the base of the transistor to protect the transistor from high flow of current. And also for the testing of the circuit, we are going to be using these 1.5 volt LED to actually test our circuit and see if our circuit is actually working. Normally these 1.5 volt battery cannot be able to power this LED, as you can see right now. Yes, so we are going to be using this Joule Thief to boost the 1.5 volt to be able to have enough current to be able to run through the LED and power the LED for it to glow. So without wasting much time, let's lay the connections. Now the connections are very simple based on your transistor pinout. Based on the BD139 which I have here, the BD139 NPN transistor which I have here, the first pin is actually the emitter, the center pin is actually the collector, while the last pin is actually the base. But for other transistors like the 2N2222A or the 2N3904, the base normally be at the middle, then the collector or the emitter varies at the two ends of the transistor. But for this, my power transistor is actually different. The base is actually in the last place, which is actually the third pin, the emitter is in the first, and the collector is in the center. So the emitter is going to be connected to ground as usual. The collector of the transistor is going to be connected to one side of the inductor, not the center tab, one side of the inductor which we have. The base of the transistor is going to be connected through the 1 kilo ohms resistor to the other side of the inductor which we have, not the center tab. Now, the center tab side of the inductor is now going to be connected to positive side of the battery. Moving on, the LED which we're going to be using to test the project out is going to be connected, positive is going to be connected to the collector side of the transistor, while the negative side of the bulb, the LED, is going to be connected to the emitter side of the transistor, which in other words is the ground. Moving on, powering our circuit, we can see that the circuit actually, wait a second, we really need to know how this circuit actually works before we power it on. Let's go to that. Now this is very simple. Now the circuit consists of a transistor and a resistor and also a ferrite coil, which consists of two coil windings. Now listen very carefully. Now we all know that the coil, one side of the center tab coil is actually connected to the positive side of the battery, and the other side of the coil is connected to the base of the transistor through a resistor, and the other winding is actually connected to the collector side of the transistor. So now when battery is connected, like example the 1.5 volt battery is connected, this flows through the first winding, through the center tab, through the 1 kilo ohms resistor to the base of the transistor, turning the transistor on. Now this actually creates a magnetic field that is being induced into the second coil, which is actually the second winding, creating another electric field that goes to the collector of the transistor. Now this magnetic field actually builds up and actually collapses after a while. Now this collapse actually creates a voltage spike. Now this voltage spike is actually a millisecond and really can't be noticed, but this is how we are going to be getting our high voltage. Now this voltage spike causes a large amount of voltage, either 30 to 40 millivolts, 30 to 40 volt or even more. Now this voltage spike is actually what we have at our collector that actually lights our bulb. That is when you can see how a 1.5 volt battery actually turn on a 3 volt LED or can even generate more powers. Now, how do we actually generate this 30 to 40 volts out of this Joule Thief? Now, we steal these spikes. I'm going to put it in this way. We are going to be stealing these spikes. Now, these spikes actually happen in milliseconds. How are we going to get rid of it? Now, these spikes are being collected through a diode and a capacitor. Now, to steal these spikes, I'm going to be using a diode and a capacitor. In other words, a diode and an electrolyte capacitor. In my case, I'm going to be using the 4700 UF capacitor, which is rated for the 35 volts, and also a fast switching diode. Yeah, a fast switching diode which can react to this high frequency which we are having in the Joule Thief. Now here is how it's connected. Now the anode side of the diode is going to be connected to the collector side of our transistor, while the cathode side of our diode is going to be connected to the positive side of our electrolyte capacitor, in my case the 4700 UF capacitor rated for 35 volts. Then the negative side of our electrolyte capacitor is going to be connected directly to ground. Now here is how it works. Now in my case, or in any case, a diode is meant to allow current to flow only in one direction, which I connected right away. Now when these voltage spikes actually occur in the collector, it flows through the diode to the capacitor, charging the capacitor up. Now when the oscillation continues, it charges the capacitor bit by bit by bit, as you can see, and this actually build up charges in the capacitor, which we actually measured with our meter, and we're going to be generating a very high voltage. I hope you really understand it. If you don't, let me know in the comment section below and I'll explain it much better for you to understand. So sorry about the noisy area, it's actually raining right now. So this is actually how we actually captured these voltage spikes. So we actually generated high voltage using these voltage spikes, storing the voltage spikes into a capacitor, measuring our output voltage on the capacitor output. Yes, this is how it works. Now that is enough for the explanations. Let's quickly go to the testing of this circuit and the practical aspect. Now we have set up everything, the capacitor, the diode, and everything up in place. Now it's for us to test it out and see if it actually works properly. In 3, 2, 1, boom! You can see that our capacitor is rapidly charging as the oscillation continues. Measuring the inductor oscillation resonance frequency, we could have about close to 10 to 11 kilohertz, which is enough and really fast to charge up the capacitor. You can see that the capacitor actually charges up very fast and quickly. We are just going to give it a little more time and let's see which voltage we can have, and let's see if we can really have 30 to 40 volts at the output of our capacitor. Okay, we are back and we are getting close to 40 volts. Just gotta wait a few seconds. Boom, finally we are at 40 volts, which is our main goal of this video. But I would advise you can also keep this capacitor to charge for a much longer time, and you can be able to have close to 50 volts or even more. And be conscious of this voltage generation, it can lead to shock, so be very careful of making this kind of stuff, and you know what to do. Be safe. And now that our capacitor is really charged to up to 40 volts or more, we are going to be trying to short circuit this capacitor to actually see if we can actually get a good spike, like a good spark. So I'm going to dim the lights right now, because you guys may think that this 40 volts or this 30 volts which I'm actually having at my meter is actually not real or some kind of fake. So I'm going to be shorting the capacitor at your front and at the screen, and you're going to see how it actually works. Ooh. Well done. I hope you didn't got scared, but anyways, we got a lot of spark. That is about 40 volts we actually shorted right there. But anyways, we come to the success of this video, generating 40 volts out of our JOTIF circuit. This is really amazing and really awesome. Now you can see how you can be able to generate up to 30 to 40 volts out of just the 1.5 volt battery, which is a very innovative project and very nice project. This was so much fun. Just want to say thank you very much for watching this video to the end, and I really appreciate you. If you really like this video, don't forget to hit the like button, subscribe to my channel, and also support me on Patreon for more interesting videos like this. And also I created a GoFundMe page campaign on behalf of getting a new device for more clear video recording. You can see using my sister's device and using my actual device. You can see the difference. I really need the device for myself. Go ahead and subscribe to my GoFundMe account, and I appreciate that, and I'll see you in the next one. Peace.